Okay, thanks, Ron. So, hi, welcome everyone. It's good to be with you in whatever time zone you're in. As Ron mentioned, I'm in Portland, Oregon. I've been with AWS a few years and have worked with a lot of retailers in my time here. My current role is head of solution architecture for retail, which basically means, we have these different technical leaders that are over different industries. And so I really look after our global set of retail customers and kind of understand what the trends are that I'm seeing, maybe what the gaps are. And then I also work a lot with our AWS service teams to make sure that we're building solutions and services that our customers can leverage and maybe remove some of that undifferentiated heavy lifting that they're currently doing today. And so today I wanted to go through kind of a talk about like how do we do that and what does that look like? How do we work with customers and what specifically does that look like? And we'll go kind of high level and then we'll also dive into some specifics. So it'll kind of be back and forth, zooming in and out of details here. But the agenda for today is we'll set the context for how we see a lot of customers in this industry moving to the cloud and what they're doing along their journey. And then we'll talk a little bit about how we co-innovate with customers. Then we'll talk a bit about how there's, of course, building block services, our whole platform that we have. And then we're going to be releasing more industry-specific services, and we'll look at a couple of them today. And then I think it would be good for us to also look at e-commerce architecture. It's very much an evolving scene, and we're constantly releasing new services that kind of make this even easier. And so we'll look at how that's been done with some demos, and there'll be plenty of reference architectures that you can go and look at on GitHub as we're going through this as well. And then finally, I just want to touch on a few use cases that are pretty relevant today on what we're seeing. I'm just calling touchless world. I mean, I think we're just seeing a lot of interest in both consumer behavior, wanting to go touchless, as well as retailers being able to provide those services to customers. So with that, we'll start with the typical retail customer roadmap. This is kind of how we see a lot of journeys happening to the cloud, where if you start over in the project space, you've usually got like sometimes it's even a skunkworks project by a dev team that's using something. They do a proof of concept, they show some value, they start getting buy-in, and then before you know it, they're moving the front end of a website to the cloud. Front ends are very common to go to the cloud first. And those can connect back to the on-premise system in a variety of ways. But then we also see at the other end is like the data lake, and like S3 as the storage platform is just super prevalent in the industry. And so once you've got your data in S3, it becomes this sort of source of gravity where more and more systems will start to put their data in. And then when you put your analytics on top of that, it becomes more and more useful. So data lakes is another pretty key and interesting like beginning workload that happens. And then migrations usually come on top of that. And that's things like just line of business applications, and then core applications like SAP or your Oracle system, your ERP systems, your planning systems will then go. And once you've got that, you've got a pretty critical mass, and you're able to actually start closing down data centers and reaping the benefits of the scalability, elasticity, security, all the benefits in the cloud. But the other thing that you get is the agility now that you're in the cloud to release much quicker, to do experiments, to try, to fail, to not have that fear of failure because you're able to innovate so quickly. And so you'll see stuff like a lot of people organizing their development teams around thinking this way so that they can have teams that are very focused on a given domain, like maybe there's a team that focuses on payments or checking out or search, and they can quickly iterate and experiment and release things through microservices. And then finally, when we get towards the kind of the top of this sort of reinvention phase, is the use of AI and ML in almost all lines of business and all different types of things. So that might be using computer vision in the store to understand what people are doing. It might be using forecasting technology to understand and optimize your supply chain. Or it might be using AI and ML to make sure that you're offering just the right offer to your customers at just the right time, personalization technology. And so we'll look at a few of those, by the way, throughout today. But this is sort of the landscape. And then now I want to talk a little bit about how do we go about innovating with customers. And so in Amazon, we have what we call mechanisms. And mechanisms are just formal ways of doing doing a process. And so one of the mechanisms we have with working with customers to co-innovate is what we call working backwards. And so the working backwards process is really just a process, and we start with the customer and work backwards from there. That's why it's called working backwards. And the reason we call it that is because it's like it sounds very simple, right? Like you should listen to the customer, really understand what they want, what they need, what the gaps are, what the problem is. And then once you are sure you understand it, you move into actually building something as opposed to maybe having an idea for what you want to build and then going and building it and then spending all this time developing the software and then throwing it over this thing to the marketing people, and then they write a press release and then eventually goes to the market and they see if it sticks or not. And then we actually think that's working backwards. So it's kind of the opposite there. But we'll get into a little bit of the mechanics of this process. It's first understanding the customer. What is the opportunity? What's the benefit, the need, and what does the experience look like? And we, actually give these out to employees in Amazon, across Amazon, not just AWS. So this is sort of a very common process for our people that are developing products to think about how they should go about the process of building products and being very customer centric in the process. And then we could spend a whole bunch of time on this process, but at a high level, I'm kind of keeping it short, is we generally write a press release. That's a one-page narrative that's written as a just a very easy to read text. That's not too, there's no jargon, it's not too technical. It's just, here's what was released today, here's the audience, here's the benefit, and here's the outcome. And you actually write it like it's a future dated press release. So you imagine what that would look like maybe in a year when this thing launches, or 6 months. And then you go and you write the FAQs, frequently asked questions, which are more like the detailed, thorny, prickly questions that you're gonna get. And it'd be stuff like, how does next day shipping work? Or what's the SLA look like? Or all these little questions that are coming. What does the pricing look like? And so that it gives you a chance to really think through a lot of that stuff and flush it all out in your FAQs. And then of course the visuals is just a way to show the experience that's in your mind, or as you, and by the way, these things sort of develop and become more clear as you go through the process. It might start with just a really rough sketch on a whiteboard, and this is an iterative process. You go and you review this with peers, they give you feedback, you rewrite it, and it takes several iterations before you get one that's good enough to actually go and do something with. And usually this leads to an initiative where you build something, or you don't, because it's not a good enough idea. And that's part of the process, is vetting good ideas. So that's the working backwards process. We do actually do it with customers as well. I'll click back to that just so you're aware of, like, so this is how we do development internally in Amazon, but we also work with customers to teach them that process so that we can help them envision an experience they want to bring to market. And we find a lot of customers really like that. Like if they're thinking of a new product or service, they'll be able to go through and write a press release, do an FAQ. And we have a whole mechanism for engaging customers on that. If you want to learn more, we can talk about it later. A couple other programs that we have in AWS for helping customers innovate is Immersion days, are where a solution architect, which is somebody that's usually dedicated to your account, your customer account, can come, previously is on site, actually come on site with your customer and then do what we call an immersion day. That's a deep dive in a specific topic like serverless or AI and ML or graph databases or whatever it is. There's just a whole bunch of different things where we can dive deep in. And that way your different teams, like maybe your data science team would come and learn about SageMaker for one day, our AI ML platform, or maybe your front-end developers would learn about serverless. And of course we can run these virtually now, but that's one engagement mechanism we have. And then design labs and data labs are kind of similar. They're just at different levels of maturity. It's like, if you want to engage even deeper with our service teams in AWS, the ones that are actually building the services and you want to get direct feedback to them, there are mechanisms for doing that where, and it spans everything from like doing design reviews all the way to actual hands-on co-engineering workshops where your engineering team can come and meet with a team in AWS and actually go through at a very like detailed engineering level to make sure that the architecture that you're building your next thing on is scalable, is secure, is going to work with the roadmap, and also gives you a chance to actually guide the roadmap because that team is hearing directly from you. And one example of this is Nike has a public story that they told at this blog that we have, where they had moved from a very large Cassandra-based cluster that stored their user identity social graph. Of course, it was like a table-based system in Cassandra. And they wanted to move to a more scalable graph database to actually store all that. And so they moved to Neptune. And of course, Neptune is our large-scale graph database that runs in AWS as a managed offering. When they did this about a year and a half, maybe 2 years ago, it was relatively new. And the engineering team didn't necessarily have a lot of deep experience in Gremlin or Sparkle. These are the technologies that are used, the interface, the programming interface to the graph engine. And so they wanted to make sure that they were doing it right and that it was going to work at scale for the scale that Nike's at, which is like hundreds of millions of users. So they did a data lab, and if you're interested, you can go watch this video. It's pretty interesting, where they've been able to scale this out, and it actually powers a lot of their experiences on like their Nike running app, for example. When you log in and you follow a runner, if you're being maybe recommended to follow someone else, a lot of those recommendations are powered through this graph database. And then there's a whole bunch of other use cases on the back end that the graph itself supports. So just one example of like how we're co-innovating with customers through these data labs. And then I want to now kind of shift into our services view. And of course, this is the traditional AWS infrastructure stack. And at the bottom is kind of your foundational infrastructure storage. And then you've got your IAM, your security, your management tools on top of that. And then you start getting into some of our more platform or PaaS offerings like a machine learning as a service, SageMaker, and then on top of there, or our IoT platform for doing command and control of things at the edge. And then on top of that, you've got more and more higher level services like mobile services, app services, dev services. And then what I want to talk about next is how are we bringing more retail specific services. And I'll talk just a little bit about like how we see services and ideas being developed. And here's just a couple different ways that this can happen is when there's there's the PR FAQ thing that we talked about first. That's one potential outcome. We also do demos and proof of concepts, and these can be done by a solution architect. We also have professional services and a very rich partner ecosystem that some of them we're just on today that can help you with these. And sometimes we'll develop source code and release that on our GitHub account that you can then use. And there's some links to that today, by the way, we'll see. And then pilots and offerings, these are just different flavors of like when a partner or ProServe has encapsulated a general way of doing something, they can bring it to you and have a more streamlined way of doing that. Like if it's a specific ERP software component that they've done a couple implementations with, they might be able to do yours quite a bit quicker than if it was a bespoke one-off implementation. And then solutions, we have a solution builder team. This is a team inside AWS that actually builds well-vetted, architecturally sound, security-hardened, documentation-rich solutions that they publish on a website with a single-click installer through CloudFormation. That's our infrastructure as code technology. So you're able to actually spin up an entire solution inside your account, which is great for teams that want to go and experience it themselves, or maybe a partner can help you with that. And then finally, the last one is the actual service, like from AWS, a first-class citizen that would sit in this landscape here. There'd be an actual service, and it would come with an SDK, which would integrate with IAM. And so you've got the same way to do permissions and all of that security profiles around all of your services. And so I'll give you an example of kind of what this looks like. And one way that you could create just a reference code as a solution architect that could be useful for customers is you could go out and build a, let's say, for example, if you're diving into forecasting, this is a real thing, by the way, that was done a couple of years ago. You can use serverless technology. I know we talked about that in the morning, like step functions to orchestrate APIs from SageMaker, which is our AI ML platform, to continuously react to, like, when new data arrives on S3, you can kick off a new training job, and then you can wait for the output of that training job, and you can host the new model, or you can optimize it, and then you can update the endpoint so that you just continuously have a best in class sort of endpoint reflective of the latest data that comes in. So as your data changes, your model might change a little bit. And so when we talk about forecasting, you could then have a UI which is powered by one of our mobile or web layer technologies, which would allow operators to get a forecast of store inventory sales, for example, at a given SKU. And then this is an example of a solution or a proof of concept which actually got replaced from a service that came that's now a first-class citizen with its own SDK called Amazon Forecast. And it makes it even easier. You don't have to write step function code or your own, any of that stuff. It's really all done behind the scenes now. And so it's really more about you feeding the data to the engine in the format that it wants, and then it will do a lot of that automatic tuning, hyperparameter tuning, and building of the model, hosting it, and making it available in a scalable way that you can visualize or interact with through an API. And so now you've got a more rich interface to do this that's just built in as a first-class citizen. And so this is just an example from the Forecast UI, where you're able to see future dated forecasts. And this is all about time series forecasting. So it gives you the mean forecasting, the P10, P30, and P99 variances in that terms of that forecast. And then this is just a customer example of forecast, Axiom Telecom, who's able to do better inventory planning and predict sales, very, very similar to what the example we were looking at, but they've seen, I just highlighted some of the outcomes, 20% increase in demonstrated availability and 15% in stock optimization. So being able to apply forecasting to different parts of your inventory pipeline or your supply chain is really actually a lot of interest right now from the industry, retail industry particularly. And then there's a couple other examples of services that have came out of this process of really building for specific use cases. And Amazon Personalize is one of them, where we took the learnings of 20 years of doing recommendations and personalized models inside of Amazon.com, and we externalize that as a service through AWS, which is now a first-class citizen in the family of services, where you can feed it data either through a batch process or through a real-time API, and it will continuously iterate on your own private model that's built around your data, that's not accessible to anyone else. It's only for your specific application. And it then gives you the ability to make recommendations for, like, what product should I be displaying next to this for this user. So at the user level, you can now have a managed service that is able to learn off of past user interactions that users have done. So the way this works is you feed the system user interaction history, and then it gives you a hosted endpoint where you can now ask for new recommendations on what you should be displaying. And then one other one I'll just call out is last week we released a service called Amazon Interactive Video Service, which uses some of the underlying technology that you see from Twitch. If you're familiar with the streaming platform Twitch, you know, Amazon acquired Twitch a number of years ago, but that technology we've now wrapped again and externalized through AWS as a managed service that you can now use. And it's so you can think of this as like a broadcast service, one to many, but it also has the ability to overlay metadata, real-time metadata, so you can push video, you can push recommendations, or you can push what's being reviewed inside of a product. And I'll show an example of that here in a minute, but this is just another example of, as we think through the different ways that we can bring things to life, ideas to life as services. So just doing a quick time check. Okay, looks like we're good. I'm going to go into e-commerce architectures, which is super interesting for retail, but other industries as well. And if we look at this particular URL, this GitHub sample, a team of solution architects in AWS put this together to demonstrate how you can build a native AWS modern e-commerce website. And so what we're looking at here, the UI is a reactive UI layer that uses Amplify, which is our UI layer that's also integrates with a bunch of other services to make a lot of the both development and deployment of your web applications and mobile applications very, very streamlined and easy to use. And so you can see it's reacting to the different form factors. That's just part of the reactive UI that they used. And then when we look at the whole sort of system architecture, I'm going to go through this in a couple of slides here. But if we start over on the left with the users, you can see that those experiences are built through Amplify. They're actually served out of CloudFront. So the way that Amplify works from a web development perspective is you build a single page application, an SPA, and that is compiled down and put on an S3 bucket essentially that's fronted by a CDN called CloudFront, which then makes that available globally, low latency to download the application. And then now the user is actually using that, and one of the first things they usually do is they'll authenticate as a user base. And so Amazon Cognito is the way that we've implemented that if you have a net new application you want to provide users for, Cognito is a good candidate for that. If you have an existing source that you want to authenticate against, Cognito also can support federated authentication, so you can integrate that way. And then that's sort of how the identity of your users is handled. Once you're in there, this particular reference architecture has gone pretty heavy on using containers as the microservices architecture. Of course, there's a spectrum of ways you can do this, everything from EC2 instances to containers to Fargate, which is a little bit more like serverless containers, to Lambda. And so this particular reference architecture sits right there in kind of the middle using ECS, or Elastic Container Service. And this is pretty similar to a lot of customers we see, the way that they roll out services. They all think of them as domains, where there's a product service, there's a user service, there's a recommendation service. And they may have different DevOps teams that do this. And that's actually how it works in Amazon. We have a lot of different teams that roll out their individual services. They own it, and that the two pizza team, and they are responsible for it. And so in this reference architecture, if we just focus into recommendations, that may be actually just a microservice that's actually fronting Amazon Personalize. So it's just making a direct integration to Personalize to say, hey, for this user that's on this page, what should I be recommending right next to them? And it would go back to the trained model that's already hosted and deployed, make a real-time recommendation, return it to the user. Now it's available in the UI. But Amazon Personalize could also be used in an offline mechanism for like a advertising campaign, for example. And this is where tools like Amazon Pinpoint come in, where they can curate and find audiences that you want to target, and then you can integrate with Personalize to find just the right product that you want to make a recommendation into. And we'll look at that a little bit in a next slide, but the idea here is you're able to leverage Personalize in both a real-time context from your users on your website, as well as like an offline campaign marketing context as well. And then finally at the bottom, this is just showing how can you use AWS native code tools to do everything from source code management to building of your code to deployment, all in a native serverless environment. So there's no managed build servers. There's no Jenkins. There's no anything like that. It's all just using native AWS tools. And so this is that pinpoint example I was just referencing, where as the user is interfacing with things, by the way, every little event that you want to track on your user's journey can be recorded back into Personalize, and you can also trigger pinpoint to send notifications at certain times. And so the way that this works is pinpoint will work with it, Personalize, to get a recommendation, and then you might want to enrich that with additional product metadata, which could be written through a little Lambda that you plug in. And that Lambda, called the transform recommendations, would basically just go back to your products database and get the metadata to send back to pinpoint, which could build out more of a rich advertisement or marketing message that could then be sent over the appropriate channel. And pinpoint supports a number of channels like push, SNS, and email. And then this is just another view of how, like if we look at number one, how events can be pushed up and put into Amazon Personalize as the user's interacting with things. We looked at how pinpoint can be used to query a product microservice. So this is just another view of showing how you may have a product microservice that's being used for pinpoint in offline recommendations, but you may also have real-time applications using that same microservice to get stuff out of product details, for example. And then finally, as we think about other channels that are supported, like voice and chat, for example, those can pretty easily be plugged in to use those same microservices. The way that you do that is by using a translation layer called Amazon Lex, which powers chat and voice applications. So you can now have an audio and a chat interface in a managed service from AWS called Amazon Lex, which then does that translation into your microservices that you may already have deployed. So you're able to continuously leverage the work that you've done on your microservice architecture with new channels by leveraging new technologies from AWS. And so here is just one last view on this e-commerce theme, where all your channels can leverage the same application architecture. Personalize, again, being at kind of the heart of a lot of these for recommendations. And then now I want to kind of click into touchless world. So we're seeing so much interest in touchless stuff right now based on what's happening with the pandemic, that I want to start with product reviews. And this is the interactive streaming service that I mentioned earlier. These are a couple examples from Amazon.com/live, which is a real implementation that you can go and view of the technology at work at scale, because we actually use it ourselves on Amazon.com. And so on the left, we have a person who's literally trying on makeup and showing how it looks, and talking about her experience with the makeup, answering questions. Chat is coming in on the side. She's able to literally read those in real time and respond and interactively show different aspects of the product. And this technology is now available for everyone, so you can start to think about maybe repurposing your employees or stores that are dark where you can't allow traffic in. Maybe you can still have sales associates working just in a new and different way. Maybe they're doing more streaming. We've had some interest there in the retail sector around that. So that's one example of using the interactive streaming service. And then of course on the right is just another use case where you've got a guy up there in a smaller frame who is talking about a product. So you can also show products on your website if you're more of an e-commerce business and maybe you don't have as much physical stores. Maybe you would actually just do a studio-based review of your website. And you can, the key thing to remember here is that you've got metadata that can come along with this, and you can push information to the user as they're watching the experience. They, of course, can react and give you feedback. But if you look at a super simplified view here, but if you imagine tying in something like Personalize, you could actually have this metadata that's coming out on the stream. If you have a user context for the actual people watching it, you can actually run real-time recommendations and send those, so you're getting even more prescriptive about what you're showing in real time. So there's a lot of ways to kind of mix and match these technologies to create new, very personalized interactive experiences. And then I have to talk about Amazon Go, because everybody knows about it. And when you think about Touchless, this is one of the leading ideas that people think about. If you're not familiar with Amazon Go, it is a grocery store, or a very small grocery store, that you could think about. The way it works is you can see you just hold up your application. There's a QR code which is tied to the loyalty application, which for Amazon is Amazon Prime. When you scan that, it's already tied to your membership, which is tied to your funding mechanism, which is your credit card. And all you need to do is walk around in the store, and you're literally tracked as you walk around using computer vision technology. And whatever you pick up will go into a virtual shopping cart that's being held. And when you walk out, you just literally walk out. There's nothing else you need to do. It recognizes that you walk out, and it will follow up with a receipt that will be sent to you in a number of minutes. And that's just to let the analytics finish processing your session to figure out what exactly you picked up. And we've had such a good interest in this from customers that we actually externalized this technology for Amazon Go. And so that is called Just Walk Out. So the technology that powers Amazon Go is now called Just Walk Out, or JWO. And there's a whole business unit in Amazon that focuses on onboarding customers that want to deploy this type of technology into their own environments, so that they can have those same experiences. Now, the one thing I'll say about this is it's its own kind of technology that's not actually from AWS. We still have so it's a different business unit right now, JWO, but we still have customers in AWS that want to do computer vision use cases inside of stores. It's not necessarily a fit for Just Walk Out. They don't necessarily want to do a full-blown shopping cart experience, but they want to be able to track things. We have partners in this space too that want to be able to know when things are out of stock, or have planogram compliance, or be able to detect spills as they happen for risk reasons. There's a whole bunch of computer vision use cases. And so earlier this year at NRF, National Retail Federation Conference, we put together a demo which showed some of these capabilities and how you could build these on AWS. And so I have a little video here which shows a camera view of some products. We've got like some toothpaste, some coffee, and as a person just took a toothpaste, a Colgate box, and then they took a Dove product, and now you can see that there's a real-time view which is showing what has been removed from the scene. So we're able to see things are being tracked through computer vision. They're spewing off events of what's happening. The events are coming through, and they're being pushed out to a real-time dashboard that shows what's taking place. And so we'll unpack this architecture here in a bit to show how that's built. But I would just say this is more of a demonstration on how you can do these sort of things. It's definitely not meant to be a full-blown Just Walk Out experience. That if you want that, you definitely want to be looking at Just Walk Out. But this will show you how you can build things like this if you have particular use cases, which we'll get into here. So this Boundless store was the concept that we built here, and this was kind of the high-level architecture of what we wanted to show. There's so much you can show to not just retailers but other types of industries, but it's very much computer vision centric. And so the way that we started thinking about this is, okay, let's let's say we want to track specific objects. How do you do that? Well, we have a algorithm inside of SageMaker that can do custom object detection. And so the way that you use that is you feed it objects of a certain thing, and you basically label it. You say, this is what Colgate looks like. This is what Starbucks coffee looks like. This is what, you know, Dove shampoo looks like. And so to do that, you need to capture a bunch of pictures. Then, of course, there's a number of ways to do this. The way we chose to do it was to just take a bunch of pictures, and then you need to be able to segment that or draw bounding boxes around that, because that's the format of information that the training needs in order to do its training. And so humans currently are used to do that. There's a service in AWS called Ground Truth, which is a scalable way to distribute out that work. If you're familiar with Mechanical Turk, which is a long-running AWS service that's used to send out work to people that actually work on things for a fee per item fee. This is similar, where you can have your own private workforce, but maybe it's just in your company, and they would all do the labeling for you. And of course, they're just, you don't have to pay, you just pay them through their normal salary. But anyways, however you do it, whether it's a Mechanical Turk or your private workforce, you end up getting a data set of information that has the annotations that you need to feed to the training process, which SageMaker then takes care of. And once you have a model that knows what these different objects looks like, you can then deploy it down to a camera if the camera can run the model locally, or you can deploy it to an edge device, which can integrate with cameras inside your environment. We have a number of edge devices and partners that are able to do that. We have a whole IoT and Greengrass connectivity model that we can share with you on if you're really interested in that. And then, of course, we have hardware that's actually coming from AWS, like Snowcone, which is able to run compute locally at a form factor that and cost that's maybe a little bit more applicable for scaling out on thousands or tens of thousands of store locations, for example. So once that model is developed, again, you can use that for that real-time identification of what's in a scene, and then that information can be sent over to like an event bus, where you can then drive other behavior, like you might be pushing that information to the UI, like we just saw in that previous video example. But you might also drive some, you know, another use case, what we were thinking about, we didn't actually do, is could you look at the people inside the store, and could you actually maybe make a model that tries to recommend just the right product to just the right audience at just the right time? So, you know, think about digital in-store signage. There's definitely ways to use computer vision or other sensors that are maybe not computer vision based inside the store to have more dynamic real-time marketing inside the store. And then another thing that we wanted to show in this demo was how you can use RFID technology to scan inventory to get real-time streams of information coming up to the cloud that you can hook into and have for other reasons. So the example use case there was, if we're continuously scanning what's inside the store, we can, as product levels change, they'll actually just hit the product database or the inventory database, and that will actually reflect through a push notification to any active session that's on the eCommerce website. So you'll actually see real-time inventory being pushed, so you can no longer put that in your cart, or, oh, you're about to check out, sorry, that's actually not available anymore. So you can literally like get down to that, when we say real-time, quite a bit more real-time, like we're talking seconds as opposed to minutes, hours, or days. And then on the right here is kind of some of the actual services that we used. And, you know, if you look down at the bottom, you can see that AWS Deep Lens, this is a camera that we have for doing AI ML development. It's not really intended for production use cases, but it does make for good demonstrations of the technology. So we deployed the computer vision model to those cameras, and now we're able to stream up the events, and we're able to do things like update the tables, for example, when things are taken or removed. So you're updating inventory levels, and then those can be sent in a push model out to the UI, for example. And then this was just another view of what the physical demo looked like. You know, on the top we had cameras looking at the scene that we saw in the video. We also had a weight sensor experience where it demonstrated how you can use very sensitive scales to, when you take something or put something back, you can basically interpret that as a product pick or put back event. And then the same thing with the RFID is, like, as you scan things, whatever becomes available, you can send up as an event. And so a lot of this, these different mechanisms or techniques for trying to figure out what's where can actually be just turned into an event stream. We had, you know, just as we were talking earlier today, a lot of people are looking at moving towards event-driven architectures, and this is just an extension of that, but we're sort of combining physical, real-world stuff, representing events that take place, throw them onto a local event, which might be doing interactive stuff locally. It's also important to have that hub architecture in place because a lot of retail stores have offline, you know, requirements where their internet is just not very reliable. So they need to be able to operate in an offline mechanism. But then when it comes back, you have a way to batch up stuff and send it up. And in AWS, Greengrass has a whole sort of managed framework for doing that, for handling that offline and that batching and that streaming. So that's the Boundless store. Wanted to talk just a little bit about semantic segmentation. This was the ground truth example that we looked at. And again, this is the private labeling workforce would be able to come into this UI and highlight things and say, this is a sponge, or this is a you know, whatever you're trying to annotate. And the advantage of this is that you can scale out your work and you get all the data back in a way that is structured, and you can now feed it to your training model. So if you're doing any sort of computer vision at scale that requires humans to train the model, you may be interested in looking at ground truth as a part of tool in your toolbox. And then this is just an example of, you know, when the model is developed and it's deployed to a camera, you can actually put it in different environments where the model wasn't, if it's good enough, if it's robust enough, you should be able to detect the product under different lighting conditions in different scenes. Now in real life, it takes a lot of robust training to develop a really robust model. But, you know, we were basically just going for the sort of something that could be demonstrated, right? And so because you can see, like in the top picture, not every single Dove object was picked up, and that's just the level of investment that we put into the demo. You'd have to keep iterating on this, and maybe even use other techniques. Some people are using synthetic data or synthetic scenes to do training. There's a whole science around this, but a lot of the tools are there on the platform, on the AWS platform, to do that stuff if you need to. And then the one other thing I'll talk about in this kind of computer vision space is the smart cooler example, where we had a different team as a partner that actually built on AWS, very similar technology stack. They used TensorFlow. Like the example we looked at previously was using MXNet. This example is using TensorFlow. If you don't know what those are, they're just two different AI/ML machine learning frameworks. And of course, TensorFlow is probably the most popular one. All very much supported on our platform, as well as all the other major libraries like Caffe, Torch, PyTorch. It goes on and on. We have a whole spectrum of hardware. If you need to have the base AMI, the deep learning AMI, which has all of those pre-installed for the data scientist that's really interested in controlling all of the different aspects, they may be more inclined towards that one. And then there's the platform layer, which is the SageMaker, where it's a little bit more just like hosted Jupyter notebook environment. Let me do what I need to, you take care of the rest. And then there's even like higher level recognition, which is like a computer vision service. I'm a developer, I know how to send an API request, I'll give you an image, you tell me what was in it. So that's like the spectrum of kind of how you can do this. And this particular example we're looking at was built on SageMaker. Again, there's a computer vision model a camera, looking down at the products, understanding what's there. And then this is kind of the architecture view on the left, where you've got your wide field of view cameras looking down, sending frames to a Lambda function, which is able to run that through an inference model hosted on SageMaker. And so this use case is actually a little bit different. It's actually doing the inference in the cloud as opposed to doing the inference locally on the camera or hub architecture. And then the sequence diagram for how this works is, by the way, the whole use case here is you have a phone, you're able to just hold up a QR code. There's a camera that reads that, is able to authenticate you, and then unlocks the door. Essentially, you've started a session. Now you can take what you need to, close it, your session ends, it figures out what you took, and then it charges it. And so that's what this use case diagram is showing on the right, is that you know, Amazon Pay is the particular payment providing service that we used in this example, where you have an account with them, then you're able to go through that process that I just described about opening the door, unlocking it, getting that initial photo, which gets sent to the cloud. It figures out what's there, and then when the door closes, another picture is taken, and then you look at the difference of what was there, what's not there. And then that basically is what gets sent to Amazon Pay. And this is all done basically real time with APIs. Of course, Amazon Pay has APIs that you can do all of this with. And so that's an example of doing a self-checkout architecture that's, again, a little bit more touchless, not 100% touchless, because you still have to open that door, but there's definitely no interaction with a person. There's no payment that's happening. There's no touching of money or anything like that. And then I was actually just made aware of this recently. We have a team in Japan that took this concept and built their entire own reference architecture. They published it on GitHub. You can read about it if you know, if you're inclined. But you can see it's very similar. They also integrated with Amazon Pay, and this is just showing how they're using the specific hardware. This blog post actually goes into a lot of the details. If you're really interested in building something like this, it goes through in very great detail. Now, the caveat is it's all in Japanese, so you either need to know Japanese or give it to your counterparts in Japan that maybe can make sense of it. But it's pretty cool, and there's a full-blown source code on GitHub that shows how you can do all of this stuff. And then another example that we're seeing in terms of touchless, or that's being just accelerated right now. I mean, this buy online, pick up in store has been on most retailers' kind of backlog, but you know, not everybody got to it. With the current pandemic, this has really shifted, like an immediate need for just about anyone that has a store has to have this capability. And this is just a high-level view of what this, how simple this could be. You know, you need to have a scheduling app in your UI that will allow you to say, well, I'm checking out now. I want to pick this stuff up at this location. And the way that this is implemented can be a number of different ways. You can sort of pick a time in a spot, and there's a whole scheduling thing. Or another way is that when you actually show up, you actually just tell the system where you are, and then that kicks off a process for the store worker to be notified in real time to come bring it out. But generally, the way it works is your information is all managed through your eCommerce system in the cloud. This is just showing you probably are going to be using API Gateway, DynamoDB, and Lambda for your compute layer. You capture that order, you send it to the store. That kicks off a process for the worker to fulfill it. When the order is fulfilled, that updates a queue, which basically kicks off another notification, which goes back to the user to say the order's ready, and now they can come and pick it up, and they can either pick it up at a locker or the worker can come out and bring it to them. And so this is just a really simple example of how you can roll out an experience like this pretty quickly with just native AWS tools. And then there's one other kind of relevant use case that we're seeing kind of emerging right now, is just being able to have an understanding of are we in compliance with the evolving sort of guidelines or regulatory, requirements that we need to be following as a company? And so you'll see there's a lot of requirements coming out around personal protective equipment, around social distance monitoring. And so we have examples of how this is actually being used in Amazon fulfillment centers, for example. So this is an actual public video that we've released that shows how we're deploying this technology to see are workers keeping the appropriate distance. And so you can see these little green lines around each body. And when they get too close, they actually turn red. And this is just a real-time TV that's set up in an environment so people can just see themselves. And if it's red, it's just meant to catch their attention and change their behavior. That's basically all this is doing, is just raising awareness of your social distancing and giving real-time feedback. And so this is a mechanism where we're using AI, computer vision to sort of give that real-time feedback. And of course, if companies want to do this themselves, we can definitely work with you to deploy a solution like this. I mean, it's going to be very similar to what we've been looking at with a lot of those computer vision use cases, either doing processing locally, doing inferencing locally inside your factory or inside your store, and then having a real-time monitor. Or you can also stream up the video to the cloud if you want to do stuff in the cloud. We have technologies like Kinesis Video, for example, which were actually born out of the need to create these sort of real-time computer vision monitoring use cases, but they wanted the use cases demanded that processing be done in the cloud, not necessarily at the edge. So for cloud-based CV use cases, Kinesis Video is really where that plays in. And then this is just an example of what a architecture for this type of system would look like. You may have a SageMaker trained model, which knows how to identify people and maybe the radius around them. However you do that, you can definitely use SageMaker to build that, to deploy it, to host that inferencing. And then your real-time camera feed would be connected through Kinesis Video, for example, if you wanted to do it that way, which would be doing continuous inferencing on the video frames. Or of course you could do that if you deploy the model to the edge, and that would essentially give you an event stream. Again, you're seeing this theme of event streams where if people are breaching, you now have like a breach event that you could then put onto a platform like Amazon EventBridge. EventBridge, of course, you've probably seen a couple times through the talk today, is a really good platform for publishing and subscribing to events. So with this, it's a very scalable way to say, hey, something's happened. I don't even know if anyone's interested. I'm just gonna publish that as an event. And subscribers, if they are interested, can subscribe to that. And then they can drive that into certain behavior, which might be responding to the event with a Lambda function, or maybe forwarding it to a queue or a notification topic like this SNS, for example, which could push out an alert to somebody that needs to be made aware of a given event. And so just kind of a simplified architecture to demonstrate how this could be deployed. With that, I know we only had an hour, so I think I want to just pause here. And yep, I think I'm at the end. So I put my contact info here to make sure, if there's anything you want to follow up with, I'd be happy to do that with you directly.
Paul, I thought that was very informative. As I was listening, I always learned something new, but I could also see a number of people in many other fields and many other industries can readily see the applications. Maybe you use some of that contentless checkout in a pharmacy within a hospital. You talked about healthcare applications. Maybe you're a major industrial distributor, similarly with like a tool warehouse. When you look at all the video capabilities for any kind of general customer service, be able to stream that. Interesting how Amazon is using a gaming platform to now enter the enterprise world. So my son, who's on Twitch way too much, no offense, Paul, but he's on it way too much. Suddenly understanding how Twitch works, now you get some experience there. You can look at enterprise applications for that video streaming platform. So there's lots of very corollary benefits. as companies look at some of the evolution which is happening at light speed in retailing and consumer goods. And hopefully you can have some takeaways from Paul on how that could be used in your environment. Does that make sense, Paul?
Yeah, absolutely. Yeah, Twitch is, it's like all of the kids doing video games and stuff are going to be the next wave of programmers, I think, because they already know how to think like this, right? And so it'll be interesting to see them as they mature into working people, right? But yeah, thanks, Ron, for having me. I'm glad to spend some time and kind of share what we're doing in the retail space. And again, if anybody wants to reach out and you want to kind of connect, I'm happy to do that with you, particularly in the retail space.